And we are live. Okay, we are live. So, okay, just quick setting. We are also live. So, it's been another week, another battlefield of wires, code, and sleep deprivation. This is episode 2 of what I have built this week. I'm Shaurya alongside with Soham. No spectators here, only builders. So, let's report in and let's debrief. So, Soham, how has this week been for you?
Oh, this week has been really challenging for me.
Uh-huh.
It was really not just estimated to something built that we have been talking in the first episode, but it was mostly also about the administration and some few challenges that I had to face with my project, the earlier project that we discussed on the first episode of Build Talks.
Uh-huh.
So yeah, overall it was a very challenging week as well. So yeah,
It's always challenging as a student, when you're making
yeah,
and
totally.
you're doing shit, it's always challenging. So, from the last podcast, I remember that we cancelled one episode in between. Want to tell
Yeah.
about why we did so?
Yeah, well, the episode was planned really well before after the first episode. Uh, we were actually very hyped up regarding the second episode, but due to some we had some commitments, both of us, which we
Mm-hmm.
had to make, and it was not really fitting in the timeline of both of us. So yeah, we decided to postpone it further because we didn't want it to rush things together. So yeah, that was the scenario basically. So, but we are back again. We are back again with the third episode. Oh,
Yeah,
sorry, second episode.
sure.
Yeah,
Soon we will be back with third one. I hope we
sure,
get
sure.
guests this time. Anyways, so, what have you been building this week, or what have you been doing this week?
Oh, I was not really building anything, but yes, I was digging in my project. I was trying my best to advance it to a next level, discussing about everything related to radiation and everything. So, as we discussed earlier, we had a problem of procuring radioactive sources.
Uh,
So, there's a good news that we have procured successfully some radioactive sources.
what
So,
what did you procure last time?
after a
I
few
found out
applications
you were.
and
I was last time we found out. So you were almost on the illegal bullshit dealing with strontium and all.
yeah,
Strontium? No, not exactly strontium.
yeah,
Hermetium, I guess.
yeah, yeah. We were
So
planning to use americium because we were basically we didn't had anything. But now
uh,
we have, instead of one radioactive sources, we have three radioactive sources right now.
so is this time
So we
also
have
illegal shit?
cobalt 60 with us.
Okay, so this time
No,
it's
no,
legal, right?
no, no.
Okay,
Yeah,
you
yeah,
got
we
illegal
are
shit again?
fully secured. Uh, it can be legal, but no, we are using it for educational purposes. So yeah, we
Okay, so is
don't
there
have any
like
illegal
is
shit
there
right.
any use of cobalt 60 in nuclear programs by any chance?
Yeah, actually, cobalt 60 was the result of a nuclear fission reaction in the reactors.
Okay,
Uh,
okay.
like it was a artificial isotope that was developed in the nuclear
Uh-huh.
reactors. So it is not a natural occurring substance. We have artificially
Huh.
produced it in a nuclear reactor. So it is dangerous if we use it to a certain extent because it emits highly beta rays that emit further calcium, which can cause cancer if we don't use it in moderate amount. But we are good. But we are good. Let me tell you, we are good here.
But I thought beta rays would make me a beta male, but okay, anyways. I
Okay.
am a sigma male. Which which radioactive source gives sigma rays? Tell me this thing.
No, no, we have yet to discover that. We'll surely discover that in the near future.
I I
Yeah.
think you should, start your academic work on making sigmanium or something like that.
Yeah, sure. Sure. It will be some highly radioactive, I guess. It will
Yeah,
surely be
only
something.
only emitting sigma waves.
Yeah. Sigma.
From sigma, I remember we don't have one of our guests today, which is Arpan.
Yeah, yeah,
Anyways, he's busy also. We won't, falter with that. So, yep, you got radioactive material, which is pretty nice.
yeah.
And what else? What else? So, what happened when
Uh,
you tested it with Cobalt 60? Did you test it with Cobalt 60?
Yeah, yeah. So we basically tested it with Cobalt 60 as well as we tested it with strontium 90. So
Okay.
results were very like not as we expected because after we did some testings, we found that the radiation levels of Cobalt 60 are really like something. They had very high dosage when they came in contact with the Geiger-Müller tube, basically the cathode ray tube. So it was really something new to understand that the dosage levels of highly radioactive substances versus the raw background radiation that we often take for readings. So it was something to discover as well as for experimental observation as well. So yeah, that was something to learn. That was good. Yeah.
Okay. So, at the end of the day, you're finally working with radioactive stuff.
Yeah, yeah. We are currently working with radioactive sources. Yes.
Uh, so, how did you procure that?
Well, procuring that was a very tough scenario because it was not limited to projects or anything because we needed to take permissions and everything, applications as well from senior authorities, etc., etc. But after that, we had our intentions clear. We had our intentions and aim pretty clear, so we pulled it off finally by procuring it successfully. So
So,
yeah, that was the case.
what would be the cost of, this Cobalt 60?
The thing is, it's not more about the cost, but it's more about the security clearances of procuring such materials. So Cobalt 60 can be obtained, but the legal processes and everything is very hectic to perform, especially for
So,
amateur students like us. Yeah.
but still, what can be the cost, like how much? 10K, 20K, 30K.
The thing is that according to my experiences, every apparatus or everything that we see in any like nuclear physics laboratory or any atomic sciences basically is above 50K. I'm telling an average, like if you see a dosimeter or any appliance that we are using in lab, its average is greater than 50,000 minimum.
Okay. Okay.
So we can
That's
take that margin.
so how much CB60 you got?
I've got a basic block of it, Cobalt 60.
Like,
I have
so
not
you can touch
yet
it with
unpacked it.
hands?
Yeah, we can actually. I have it
Won't
with
you
me
get
right
any
now.
kind of cancer or something?
No, no. We have it very safely contained. And also, I think there are some restrictions that we have taken into account because as this was procured from my lab, basically, as you can see here, I don't know if it's visible or not, but yeah, you can
Send
see
me a
it.
photo. Send me a photo. I'll get it on the screen.
Sure.
So you got Cobalt 60. Can you get
Mhm.
C14? C14. C14 seems to, okay. He's gone. He has a pretty bad internet, I guess.
Mhm.
Okay, you are back. So I was asking you about, can you get C14? You are gone. Yeah, you are again on this stream. I was asking you, can you get C14? Can't hear you, can't hear you.
I
Fix your
just
net.
mentioned that laboratory is not the safe space for that, into my opinion.
What laboratory? Kya? What? Can you come again? Where did the lab rats go? Okay, so the image Soham was saying, he has shared me that image. Let me get you through that C60 image. He has sent me one image. I'll get you that image. Image. Where is that image? Image. So, yeah, it's here. So I guess you guys can see this image. There are three blocks. Som, can you see the image?
Um, Wait a second.
Can you see the image?
Nope.
I've I've
Yeah,
screen
yeah, yeah,
shared with you. I've just placed it between us, Anyways,
yeah,
yeah. So
yeah.
what is this thing? Why this looks like?
So, okay. So there are basically three blocks here. Each block
Okay.
contains an isotope.
Huh.
The first block is of cobalt,
Okay.
60.
Okay.
Cobalt 60. Actually, there are two blocks of cobalt 60. I don't
Okay.
know why they have given me two blocks, but let it be. So there are two blocks of cobalt 60 here.
See, the more you get, the better.
Yeah, yeah, yeah. We
Huh.
love data. Yeah.
Huh.
Yeah, so there are two blocks of cobalt here, and the third block is of
Huh.
strontium. Among
The
them,
last one, right?
cobalt, yeah. The thing
Vertically
is that,
last one.
yeah, vertically last one.
Huh.
So the thing is that strong cobalt 60 can be managed. The radiation that it will emit will be comparatively lower.
Uh-huh.
But
Okay.
strontium is a bit hazardful if we are not if we didn't take precaution about it. Yeah.
Okay. So, like, is this a plastic case or something?
Yeah, so the outer covering, so I mean the box or the chamber of it is like plastic and wood basically. But yeah, the like the minerals or the thing which is used is mostly, I guess, some kind of plastic or acrylic, I guess, in which the minerals are somehow cremated or something, in my opinion.
Okay.
I don't have
Okay.
much knowledge about that, but yeah,
Get
that's the
uranium
plan.
next time.
Surely, if
That's
I don't get any sanctions further. So I may.
so you got sanctioned for this one? Is
No,
that
no,
so?
I didn't, but there was like heavy checking of me. Yeah, they almost
Heavy.
like yeah.
What is heavy? What is heavy checking? Now explain
Like
this fucking term which you used.
so like I had to submit my ID cards, my Aadhaar cards, my like everything that proves that I am citizen of this country and this college. Let me tell you that. Yeah.
Just to get this fucking wrong, you just submitted your Aadhaar card and all. Yeah. Crazy, way
Yeah.
crazy. You're doing
Yeah,
good.
Yeah. I also had to write, basically write a letter to my principal, because of that I have the authority of this and everything. So yeah, it was very crazy to procure that.
Just imagine learning how to write a letter to the principal for this shit. To the principal for Gibson College.
Yeah,
Subject.
literally I have written that. Yeah, my subject
Subject.
was a temporary procurement of radioactive sources for academic purposes. This was my subject.
Radioactive shit for academic purposes. See, I ain't gonna build some nuclear state. Just hand me
Mm.
some good material.
Yeah,
So
totally,
there,
totally.
you know, uh, even if you got radioactive material with that many checks, let me tell you one thing. There is this exam called ham radio. Okay.
Okay, yeah, yeah, yeah,
So ham radio is like a hobby. It's not actually pig and radio because
yeah,
mostly people,
yeah,
take ham for pig.
yeah.
So it's not a radio for pigs. It's basically people who piggyback on radio frequencies. So
Mhm.
ham radio is like you get a license, so you can make your own radio station. You can
Yeah,
communicate on many frequencies: AM, FM, shortwave, UHF, VHF, and all those things. Yeah,
yeah,
millimeter wave, micrometer wave, and all these things.
yeah.
So just to get that one license for like that radio stations and shit in India, it
Hmm.
takes way more checks than that. And specifically, if you are,
Okay.
you know, getting that license, first you have to give two exams. One is for
Yeah.
rules and regulation, and
Hmm.
second one is of technical education. So
Okay.
the technical education one is there in which you get basic electronics and all that shit,
Yeah.
and one is there for rules and regulation where they teach you about how you have to chat. You don't have to use any political topics. You don't have to bring in religion slurs and all those things. And there is a language also like 88, 66, 89, 69. All these numbers mean something in that radio chatter.
Okay.
So just to get a transmitter license, because you can listen to it for free without
Yeah.
license, you can listen to
Yeah.
even aviation band. So you can
Yeah.
make your own receiver and listen to the aircraft radio. But the only thing
Hmm.
is for transmitting on the not aircraft frequency, on other frequencies, the
Yeah. Yeah.
communication ones, on
Hmm.
that spectrum you need a license, and for
Hmm.
that they even send you police at your home, so that
Okay.
they can check
Hmm.
that you aren't any spy or transmitting any material, because basically
Yeah.
you also have to give a Morse code exam if you are giving for general grade. There are
Yeah.
two grades: restricted and general. Restricted doesn't give you transmit permission to transmit Morse code,
Yeah.
and general gives you permission for that also.
Yeah.
So they send police and all, and you have to maintain registers even if you get any contact. If you are like talking with someone on the radio, there is nobody to check you, okay?
Yeah.
Especially on radio, because these can't be checked.
Yeah.
So like, if you are understanding what I am saying is,
Hmm.
this is purely unregulated territory of radio.
Hmm. I get it.
How should, how should I tell you? It's basically pure radio, right? It's pure radio.
Yeah.
So, okay, just a second. Okay, so yeah, I was wrong at one place. Journal gives me more bands. So
Hmm.
basically, there is a whole spectrum thingy in which you can, talk with other people. So let's say I make, let's say, a trans receiver for 100 megahertz, and you make one for 100 megahertz. Then we can communicate with each other. Okay.
Hmm. Hmm.
So there are many things like your transmission power, receiving power. These are technicalities, okay? You have to, go into the radio physics or the physics
Yeah.
related to radios and shit, or,
Hmm.
electronics. Basically,
Yeah.
we transmit at a certain power, we receive at a certain power.
Mhm.
So, there are many things. For that, you have to maintain a register. There is an annual register checkup which is done. So the police people or people from the telecommunications department come to your house, check that
Yeah.
register, and in a time of war, all your shit is going to be locked inside
Mhm.
a cabinet with a seal.
Okay.
So you can't operate a radio during a war. It's
Yeah, yeah, yeah.
it's kind of censorship, but it's good. It's good. And secondly, there is one more thing that Indian government promotes ham radio
Yeah.
because in time of natural calamities,
Mhm.
uh, you know, when there are no other infrastructure for communication, government calls you up कि भाई आ जाओ, volunteer करो, मजे आएंगे. So you have to work on natural calamities also. It's gone again. Deepak. Where has he gone? Okay, let's wait for him to come again. Then we can resume. This guy is never on time because he got some fucked up internet. So he's always, in and out and in and out. So we just have to wait for a few minutes. He just messaged me up that he's gonna come back. So okay, there is this one thing. Arpan has been messaging and doing shit on the comment section. And I timed him out for 24 hours and he came again with another ID. The only thing is, I know that this ID belongs to him, so I'm again going to put him in under timeout. It's kind of censorship. So he's joining up. We still got to, wait for him. We are going to set up a good Wi-Fi connection at his place soon. So I mean, I'm not going to set up anything. He's gonna get set up a good Wi-Fi connection. So yeah, till then, I was telling you about ham radio and things like that. He was he came again with another ID, and we just put again put him again on 24-hour timeout. He's coming with different IDs. He's spamming shit. Okay, so let's see if Som comes back. So I can't see him. Just a second, guys. I'm gonna put you guys on. I'm gonna put myself on hold. Otherwise, we will, review. our old YouTube channel. I got a very nice thing to review today. So going on a small hold, guys. Small hold, very small one. Okay, guys. Okay, I'm back. I'm back. So the thing is, his internet is quite fucked up currently. Let's review some shit if we get enough time. Okay. So we are going to review about shit. I'm gonna show you the material. I'm sounding quite, stupid saying this shit, but it's okay. So we are going to review my other YouTube channel, which I opened up, which me and my team made, so that we can teach people electronics. And at that point, to be very honest, we were in class 8th and ninth, and we were not having, a lot of knowledge about electronics, but we were trying our best to get into electronics and teach people a lot about electronics. So we created this channel. Let me show you this channel. Let's go to display capture and okay. Hope you guys can see my screen. Yes, now you guys can see my screen. Okay, so this was the channel. This was the channel we started up, and yeah, so basic electronic tutorials and all those shit. Let me show you this video first. Okay, okay. I guess someone here just did some stupid stuff. But anyways, uh, I'll just turn this off. So basically, the video is taken down by Arpan. You guys can, spam to his comment section, to his inboxes in the email. I'll provide you one. I'll dox this, this much things. I'll do doxing here. Although it's a felony, but I'll commit one. So he has just removed that YouTube video. Anyways, okay. Can I remove the timeout? No, I can't. Okay, so anyways, what else we were talking about is that this week, what I have been building is quite amazing. I think at least so, that what I have been building is amazing. Let me show you what I have been building. Okay, I guess Soham is trying to join back, but till he joins, we are going to, start with my project. So here you can see this board actually. Just a second. Okay. Yeah, so this is a board which was made by Hatch and Hack Electronics. They have their, if I can just, rotate this. Rotate, okay, okay, wait a sec. Can't I rotate this? Yeah, okay, I can make it extremely small, but I need this rotated, okay. Okay, so just give me a sec and I'll rotate this image at the source. Here, okay, okay. Where is the stream? I got to edit it, rotate, yes. Okay, so this is rotated, good enough. So I was thinking about starting a new project called the Model Rocketry Control System. So this project is quite ambitious, I guess. But anyways, so this board here is called ARBD1, which was made by Hatch and Hack Electronics. Their channel is gone now. Channel in the sense, yeah, they were a startup. They even had a YouTube channel, a website, and everything. Now they are just acquired, and I don't think they make this anymore. So I got this product as a gift from H&H. Uh, Mostly like sponsorship because we also started a startup called the Electronic Learners. So they gave me this board for free. Uh, so we started, many projects on this. I personally did many projects on this one. So let me explain you what this is. So if you can see on the top left corner, there is something written as pot. So basically this was a 10K potentiometer. Then you have your LCD display here, which is 16 by 2. Then you have Charlie Plex LEDs. There are 12 LEDs in this. Then you have three LEDs for RGB lighting and all. Then you have this keypad matrix. So this was basically a matrix keyboard of 8 by 8 or 4 by 4. I remember. Yeah, 4 by 4. And they have got even shift resistors in this place. Then you have got navigation switches. So what these switches were used for is you can just make anything like a game or something and you can navigate on that game and display. So what they were trying was they tried a very different approach, which was they used only one analog pin and they made a voltage divider. So they took a reference voltage of I guess 5 volts, and for every switch they added one extra resistor. So this is a very, for me, it was at that time a very good approach on approaching small problems like this. Like you don't even need four switches, you just need one pin and five switches with different voltage levels. Then they have got a Bluetooth module. It was a HC6, I guess. No, it's not. It was HC05, so it was a Bluetooth module. Then above the Bluetooth module, you have got a India, and then above that is a DHT11. So this sensor is for humidity and temperature. So it's a digital sensor, although I don't trust digital sensors a lot in these kind of scenarios. So the project I was thinking about is quite ambitious. What I was thinking is that we should make a software for this. Before starting with the software, we'll start with the schematic diagram and everything. I have to reverse engineer this thing, and then once this is reverse engineered, then I can go through the whole firmware. So the firmware would be like you can communicate with your rocket via Bluetooth, and you can manually configure everything you want on this board rather than on any, other thing. So you can configure your like servo fine tuning, and you can configure your voltages, your other datas and all. And because we have a keypad, so you can even sync in many other things like anything. Then I was hoping to use a LoRa with it, especially in SX uh 1278 or 1278 module, if I'm not wrong. Let me just show you what that LoRa module looks like. LoRa 1278. Although LoRa SX 1276 is a better module, but I think, yeah, it's 1278. So if I can just show you my screen, that would be good enough. Wait, I'll try to show you my screen, and then we can see what that LoRa module looks like. Okay, now where is browser? I'm just going to see this image. So, let's see. Browser. Okay. So I guess you are able to see. Mm. So this first module, this blue color one, SX70, SX1278, this is a LoRa module. I was hoping to use this one. It's good enough for range and everything, and because it's an open environment, so for that it works pretty good. So I was hoping to use this. Then, I can set up a whole uh, thing like firmware and everything, and we can even receive telemetry on this uh, board, like altitude and everything. So I was hoping to make this thing. Other than this, I also have one more ambitious project which I'm working on. I'll kind of want to share you. I would like to share it to you. Just it's Let me just get one image. So because it's a FSM rover. So what is a FSM rover? Let me just open up Microsoft Paint and show you what a FSM rover looks like. Okay, okay. I guess I can go with a window capture and Microsoft Paint. Okay, I can just, if I can, place it here. I'll just remove this image. Hmm. Okay, so I guess you can view Paint or no. No, no, no. Oh, what the hell? I can't show you what I'm doing on Paint. I can just show you that I'm scribbling on something that's kind of bad. Setting for OBS. Wait. Let me get that thing. Okay. I can't get that as a media source. First, I have to, then I have to, I guess, change this, that, no. Why isn't this working? Okay. Okay, I'll do one thing. Color source, display capture, game capture. Let me try with the game capture feature. Hmm. Okay. We'll do it as game capture. So I'm a bit new to OBS. Anyways. So, just do it again. Where is game capture? Game capture, game capture. Okay, I have added game capture, I guess. Any specific window and paint. So I guess you can see what I'm drawing. Okay, this is good enough. I have to, erase this. Then only I can. Array, spoil, start. But okay. So before I explain you my project, let me just grab the screen and fix it somewhere. Okay. So now I'm going to tell you about my this project, which is another project. So it's basically a FSM rover. Now, if you are going to ask what is FSM, so FSM stands for finite state machine. So I can just write here FSM rover. This is my project. Don't tell me you can't see. I guess so. FSM is finite state machine. I was thinking of using Murray's machine because Murray machine is quite better. I hope you guys can see what I'm typing. It's shit. Yeah. So I was thinking about a FSM rover. So I want that rover to follow a square. Now, how will it follow a square is, there will be a path like this, and like this is the path. Let's say I put my rover here. This is my rover. Then it will go here, then make a turn. At this point, it will turn here and come here at this point. I'm pretty bad with drawing, I know. Then go here again, then make a turn here and then go again. So this is what I was trying to make. But for this, I now how I'm going to do this is quite interesting. So if you know L293D, L293D, it's a motor driver, it's a MD, but it's a H bridge motor driver. Mostly motor drivers are H bridge only. So what this helps with is, so specifically motor drivers, have this one capability that every motor can be used either in this direction, let's say it's F forward, so FW, or it can be used in another direction, which is backwards, which is BW. So a motor driver has two pins. So those are like one buck strip like this, and then there are two ports like this. So this buck strip, let's say it's the FW buck strip. So I'll just note it by F and this one as B. So if I power this one with let's say 1 and this one with 0, so my motor will go in forward direction, and if I do vice versa it will go in backwards direction. So if you see here, if I use at least two motors, I can control my motor driver using a 4-bit number. So a 4-bit number would look like 1010, let's say. So this is the code for, forward. Then 0101. This is the code, let's say, for backwards. Then we got another code for, let's say, turning right. So turning right, let me assume T one motor is this and one motor is this. So this is the left motor, this is the right motor. So if I want to turn right, I am at this point and I want to turn this ways. So I have to, either turn this motor forward and this motor backward, or I have to stop this motor and only turn this motor. So for turning left, I can have two codes, which is either 0010, or the another code would be 0110. So there are two codes for turning, left. So what you ask, what is the difference? So if I use the code 0010, what will happen is this motor will stop and this motor will go on. So it will make a sharp left turn. But let's say I use this code 0110. It won't be a sharp left turn, but it would be a pretty decent left turn, but it would be way faster than 0010. So, I have to make a sequence generator now. For a FSM, I have to start with a sequence generator. Now, what is a sequence generator? Sequence generator is, cyclic circuit which can generate one, zero, a sequence, any sequence. Let's say I make a sequence of 100, 10110001. So let's say this is my sequence. So sequence generator is capable of generating this sequence again and again, again and again, like a cyclic process. So first I was thinking of making a sequence generator, but then I thought no, sequence generator is not going to be good enough for this job. So now I'm shifting to FSM, which is again pretty hard, to be very honest. But I guess we will make it. So the current challenges I'm facing right now, and I'm researching and seeking help on, is that if I make a FSM, how would I time everything? Like let's say for my turn, I have to take a 6 seconds turn. That means I have to use my motors for 6 seconds, and then only I can achieve a turn. Or let's say this forward path is gonna, take around a minute. So I have to continuously feed in a sequence of 0110 10 for let's say a minute. So how would I, know that this is going to happen? For that, I thought of using a PIPO. So a PIPO is a shift resistor which is parallel in, parallel out, and I was thinking of using a PIPO with a latch. So what does a latch do is it fixates on the outputs it's trying to send, and that output stays. So what do you mean by that output stays is that let's say I feed in the output 1010. So if I have enabled the latch on, so it will hold on to that output until I, send a new output and, reset the latch. And then if I latch again, it will continuously hold that output. And then again, the same thing will happen. So I was hoping to use a PIPO with a latch. So it's a PIPO WN. So this was my initial plans, and then I was thinking of using as also a RC timer circuit, which I was hoping to make with any 555, the most important timer IC. But now the problem is my FSM works on a different clock rate. So let's say the FSM which I'm, making here runs on 6 clock pulses. So these are 6 clock pulses. it gives me one sequence, right? In six clock pulses, it gives me one sequence. So, and let's say in one clock pulse here in the people, I'm getting the data transfer. So you can say DT. So if you see there is a mismatch between the clock pulse of the six the FSM and this where it is one this PIPO. So now this is bothering me. Before I was thinking of using RC circuit so that every six pulses won't matter. Like what I am trying to say is, let's say I have to hold on to this sequence for let's say 1 minute, right? Let's say I need to hold on for this to this sequence for 1 minute. Then I'll make a RC timer circuit for 1 minute specifically for people to hold on to that, and another NE555 RC timer circuit specifically for the FSM just to hold to the state. So we will have this timer circuit, the one for FSM, working way faster than the one for people, because whenever let's say I'm going to hit this turn, so before at this point only I can have my data transferred to the people. I know it's a bit confusing. For me also it was a bit confusing, but if you are following this live, then suggest just going through it again. It's quite interesting project, although it's a fun project, but I think it's a very interesting project. I have shared it to my mentor also. She said it's kind of interesting that I'm using a simple topic in a way complex thing, because I'm just complicating things out, or you can say I'm just over engineering on a simple topic. I can easily use a MCU or other circuits, but I just wanted to learn FSM, and I know it's hard, but it's really fun way to learn FSM. So yeah, so what I was hoping is that we get the finite state FSM timer a bit faster so that we have our FSM states ready, and the PIPO timer at different timings. So let's say at the first sequence I want to hold on for 1 minute. So I'll have a timer for 1 minute. Then let's say I have to hold on for 30 minutes. Oh, sorry, 30 seconds. Then I can hold on a timer for 30 seconds, then 1 minute, and then 30 seconds. So we can get these timers. So I was thinking of using two timers, but then I said the maths is not going to be good enough. So now I'm going with three timers instead. One for 1 minute, then 30, then one. And for maintaining the sanity of this whole timer circuit, I'm going to use one more additional timer that is going to flick relays. So how that is going to work is that it will flick multiple relays. So there are going to be four timer circuits, one for 1 minute delay, one for 30 seconds, one for your FSM, and one timer circuit which is going to hold the relays for this 1 minute and 30-second circuit. So it is a bit shitty, this idea. I hope you guys, give me some comments or a suggestion in the comments that how I can solve this problem, and maybe I can make this one way sooner than I expect. So, yeah, that is it. These are all the podcasts which I have been, these are all the projects which I have been doing for, past 1 week. Other than that, I was a bit busy on other things, such as we were working with that Geiger Mueller counter, which I and Soham made. So we were a bit, uh, kind of packed up on the schedule for the GM counter because he has some exhibitions coming up and everything. So there are some errors which are there. We have to solve those errors, then check at different things. So because before making the GM counter, we were not having the radioactive material, but now we have the radioactive material in hand, so we can actually test the thresholds at which it is going to work. So most probably it will work fine. Yeah, and yeah, that is it for today's podcast. I'll say hope to see you again. Till then, keep building, keep enjoying this journey of making things, and